And hello again, my little mathematicians. I just wanted to do a quick little review with you before you're ready to take your test. So, quick thing, you should know how to do all of these. So, I would go ahead and try them yourself and then come back and check yourself. So, pause the video, try them, and then unpause it and come back. Okay, so one thing I wanted to point out is that on numbers 1 through 4, practice on showing the inverse step. Like, for instance, right here, what's the inverse of subtracting 5? Adding 5. Why do you do that? So that these cancel, and then you have a by itself. And whatever you do to one side, you have to do to the other. Now, 82 plus 5 is 87. Now, a lot of you are like, I didn't need to do that. I could already just do that in my head. Okay, but remember that points will be deducted from your quiz or your test if you don't show your inverse step. Okay, we give you baby problems that you can focus on showing the inverse steps for when problems get harder. Okay, so that's what we're really testing you on, is showing the inverse step and practicing the inverse step. So that then when problems become harder, it becomes second nature. So we give you baby problems so that you can actually just do them in your head. Now, with that being said, some people quickly do it in their head and they're like, okay, so I'm going to add 20 and 40 plus 20 is 65. Okay. Now, one, you would have gotten points taken off because you didn't show the inverse step, which was to subtract 20, because 20 minus 20 is 0. And whatever you do to one side, you got to do the other. Now, is 45 minus 20 65? No, it's not. Okay, but let's say you just weren't paying attention and you accidentally added those. Hopefully, when you go to actually check your work, the original equation is c plus 20 equals 45. Well, you're going to replace the c with what you think it is. You think c is 65, okay? And then when you go to check, you're like, wait, 65 plus 20 is 85. 85 isn't equal to 45. That's not true. Oh, maybe I made a mistake. Oh, 45 minus 20 is actually 25. So let me try plugging in a 25 there for C. Well, 25 plus 20 is 45. Bring down your equals, bring down your 45. That's a true statement. Okay, so 25 must have been the right answer there, not 65. So checking isn't just busy work, it's to help you catch yourself in case you make a silly math error. But what I recommend is, well, several things. If you ever see it written horizontally like this, maybe rewrite it vertically. This is still saying y divided by 2, okay? And then that way, when you go to show your inverse step, you can see y is being divided by 2, and the inverse of dividing by 2 is multiplying by 2. So that those cancel and become 1. 1 times y is just y. You can do that as long as you multiply this side by 2 as well, and 15 times 2 is 30. Okay, then try your next one. The 8 is being multiplied by the f, and the inverse of multiplying is to divide. So I'm going to divide by 8 on both sides. 8 divided by 8 is 1, and 1 times f is just f. 72 divided by 8 is 9. Now what I would do is then I would write, okay, in the answer column, 1 is 87, 2 is 25, 3 is 30, 4 is 9. Then after you write those answers, then I go back to check to see if you made a mistake. Like, we supposedly caught ourselves in number 2. So to check, again, write your original equation, replace your variable with what you think it is. I think A is 87 minus 5 equals 82. Well, 87 minus 5 is 82. Bring down your equals, bring down your 82. If you end with a true statement, then you're like, sweet, 87 was right. I can move on to the next problem. But if when you checked it here, remember how we got we accidentally got 85 is equal to 45, and we're like, wait, that's not right. So we wanted to erase our work and go back and retry it and catch our mistake, and then change the answer to actually 25. Okay, then you'd move on and check this one. y divided by 2 is 15. We think y is 30, so replace y with 30. 30 divided by 2 is 15. Bring down the equals, bring down the 15. True statement, so yes, 30 was the right answer. And 30 is what you would put in the answer column, not 15. This was me checking to make sure that 30 was the right answer and gave me a true statement. Okay, for this check, you have 8f equals 72. We think f is 9. So I'm going to replace the f with a 9. 8 times 9 is 72. Bring down your equals, bring down your 72, and that makes a true statement. So 9 was indeed the right answer. Okay, showing the inverse step, not an option. You have to show the inverse step in order to get full credit. If you want to check, that's optional, okay, but it's just helpful to make sure that you get the right answer. But if you do decide to check, I strongly recommend do all the problems first, write those answers in the answer column, then go back to check so you don't accidentally write 72 or 15 as the answer. The real answers are 9 and 30. Okay, now I just said that checking is optional for when you're asked to solve a problem. But for these ones, when it says, hey, determine which equation has a solution of r equals 4, these ones checking isn't an option. These ones I want you to only just check. You're not going to try to solve because you actually don't know how to solve when r is in the denominator because it's saying 1 over r. Or you also don't know how to solve if r is negative. So we purposely give you ones that you don't necessarily know how to solve just yet when we already give you the answer. So all you're doing is you're checking, hey, is 4 the right answer for r? So I'm going to replace all the r's with a 4. So it's 4 divided by 1 equals 4. And 4 minus 4 equals 8. And 1 divided by 4 equals 4. And 3 times 4 equals 12. And 20 minus 4 equals 16. Let's see which one of these results in a true statement. Well, 4 divided by 1 is 4. Is that a true statement? Yes. 4 minus 4 is 0. Bring down your equals 8. Not a true statement, so nope. 1 divided by 4, bring down your equals 4. This is 1/4. I can't reduce it anymore. 1/4 is not the same thing as 4. Okay, 3 times 4 is 12. Bring down your equals 12. That's a true statement. 20 minus 4 is 16. Bring down your equals 16. That's a true statement. And there you go. Okay, so again, if they give you the possibility for what your variable could be, for these ones, you're not solving it because you don't know how to solve all of these ones necessarily. Like this one, and that one, you wouldn't know how to solve. So we just want you to plug it in and check to see for which ones does 4 work and make a true statement. Okay, for graphing, once you have your variable isolated, put the number you're focusing on in the middle, one bigger, one smaller, and then focus, should I shade it or leave it unshaded? Well, it's not including that point, so I'm going to leave it unshaded. And which direction should it go? To the left, because when your variable's on the left, this inequality sign will match your arrowhead. Okay, here, the variable's on the left, so I'm going to put 7 in the middle. And should I leave it open or closed? I should fill it in, okay, closed, because there's a line underneath, so it's or equal to. And which way? To the right. Because my variable's on the left, this inequality matches the arrowhead right there. Okay, it's all the numbers greater than t, so greater numbers are to the right. Now, in reverse, if you're asked to write the inequality when they give you the graph, okay, so I'm focusing on the number 6, and it's going to the left, so it's all the numbers less than 6. And I'm not going to underline it because it's not including the 6. Here, you're focusing on 5, and it's going to the right, so it's all the numbers greater than 5. And I am going to underline it because it's including the 5. All right, almost done. Let's see how you did on 10, 11, and 12. It's write the equation or inequality for each of these. It says 3 times what? Ooh, the sum of some number and 10 is at least 45. Okay, so when it says is at least, that's a form of an inequality. And remember when we see the word at or no, it's the opposite way we think. So instead of a less than sign, it's actually a greater than or equal to sign. Because it could be equal to 45, but they prefer it to be greater. And remember, when we're talking about these, it's always in reference to where your variable is. Okay, the next one says 4 less than, less than. So I'm subtracting 4 from something, and you're like, wait a minute, why is it not a less than sign? Because that would say is less than if it was an inequality sign. So I'm taking 4 away from something. What am I taking 4 away from? The product of a number and 20. So product means multiplying. You're multiplying some number and 20. Okay, so 4 is being subtracted from the product of 20 and a number, and that whole thing is less than 36. So that is less than, because of that is, it's like a form of an equal sign, and an inequality is like an equal sign, right? Okay, last one. Let's see how we did. 3 less, so just 3 minus what? The product of a number and 5. So 5 is being multiplied with some number, and that is, so equals 7. And there you go. Hopefully this helped you feel a little bit more prepared for solving, checking, and then checking them when they give you an answer like this. Again, can't emphasize it enough. If they give you a possible answer, please just plug them back in to check to see which ones result in a true statement. Then that means 4 was the right answer. And if it ended in an untrue statement, then 4 was not the right answer for those. You won't necessarily know how to solve all these. That's why we want you to just check them. And then hopefully you became a little bit more comfortable with graphing inequalities. You got this. You're going to do great.